Hi, everybody. Welcome to the season's notes. And here we go. The movement of one object around another is called revolution. The Earth completes one revolution around the sun every year. The Earth's path as it revolves around the sun is called the Earth's orbit. So the Earth's orbit is a slightly flattened circle. So revolution is we go around another object, and orbit is the path it takes. And you can see the path here of our solar system. The inner planets go quite quickly around the sun. We've got Mercury, and then we've got Venus, then we've got Earth, and then Mars right here. And then we've got Jupiter, Saturn. The next one out is Uranus, and then Neptune. And then we've got some Kuiper Belt objects, also known as Pluto, that zips around, but sometimes it's inside Neptune's orbit, sometimes it's outside. It's a Kuiper Belt object. It's no longer considered a planet. It's a dwarf planet. But you'll notice as you're looking at the orbits of the different planets in our solar system that we'll talk more about in our next unit is the outer planets have so much farther to go, it just takes them a very long time to get around the sun. So if you compare Mercury just zipping around to even Earth, Earth takes longer. Mars takes longer. Venus is faster because it's closer. So an orbit is that path it takes. Revolution is what happens when it gets one time around the sun. So as we're looking at this, and I'm going to turn off this volume because you can go back and watch it. It's 28 seconds if you want to hear what they have to say. We're going to look at rotation, and as we look at the different ways that the Earth moves. So the Earth rotates on its axis once every 24 years. It revolves around the sun every 365 days a year, although technically there's a quarter and there's a little more into it than that. But here is the spherical path as our orbit occurs. As we revolve around the sun in that orbit, you're going to see that it's a helical motion because remember, at the same time, our sun is flying through the Milky Way. So the sun is moving and we just kind of keep getting stuck going around and around and around. So we're moving, we're rotating on our axis, we're revolving around the sun, and we're spiraling away around in the Milky Way. And then again, remember the Milky Way is being flung out from the Big Bang. So at any one time, we're going in 4 different directions, and quite quickly at that. We talked about that in the last set of notes. So here's a representation of what that looks like as our solar system is hurtling around the Milky Way. We are literally always just kind of chasing it. We're not stuck in one space. Even the sun isn't. We're moving. So many cultures have tried to make a workable calendar. It's not easy because the Earth takes 365 and a quarter days to circle the sun. And 12 moon cycles makes up fewer than a year. So we can't just say a month, 12 months, 12 moon cycles. By the way, month is lunar cycles is how they originally, there was originally 10 we added 2 in. So if you ever pay attention, if you look at the septa, the octa, the nano, and the deci, those are the mathematical prefixes for septa is 7, octo is 8, nano is 9, and deci is 10. They used to be the 10th, the 9th, the 8th, and 7th month of the year. We added 2 more months in the summer to make it fit better, and they got knocked out of that mathematical position. So the Mayan calendar, we talk about that, said that the Earth was supposed to stop, and really what happens if you're a Mayan, they said, well, no, that's just when the calendar resets. But TV made a lot of money on the apocalypse. The calendar's running out, the world's going to end. Well, that was a long time ago, and we're still here, so I think you're okay. So the sunlight hits the Earth most directly at the equator, and the equator is that imaginary line that separates the 2 hemispheres. And the closer the pole points, the more directly the sun hits that. So if I look here, right here, once we get to the Tropic of Cancer, this was our, not equinox, it'd be over the equator. But you'll notice that at the summer solstice, the longest day of the year, the sun is directly overhead at the Tropic of Cancer, which is 23.5 degrees north of the equator. And you'll see that the pole still has pretty indirect light. If I can make that a little larger, you're going to notice that, see how this sun right here, if we're looking at the vertical rays, is in a much smaller area, and it gets spread out almost twice the distance at the North Pole and the southern part that it hits, because it's just spread over a longer period. That's why in the winter our sun isn't as direct, because it's being spread over a greater area because it's lower. So in the summer, the southern hemisphere is in winter, and the northern hemisphere is obviously in our summer. That's June 21st. That's our longest day of the year. It is the southern hemisphere's shortest day of the year. If I look and reverse it to when we're on the other side and the South Pole is pointed more directly towards the sun, that is the South Pole's longest day, but you'll notice that our North Pole is in shadow. That's our shortest day of the year. And that is the winter solstice, usually around December 21st or 22nd. We just passed the equinox, the autumnal or the fall equinox, which is equal day and equal night. So now we're having a little less than 12 hours of sunlight a day. But you can see again, as we're up here, now the most direct rays at our winter solstice are at the Tropic of Cancer. And the Tropic of Cancer up here, the Tropic of Capricorn, are 23.5 degrees north of the equator for Tropic of Cancer, 23.5 degrees south of the equator for the Tropic of Capricorn. And that's the farthest point that the sun will be directly overhead, direct hit. And if you're at the equator, that is directly overhead at our solstices, because it's the halfway point as it travels north and south. But it's really not the sun traveling north and south. It's that tilt of our axis. So you see really what's happening is this 23.5 degree tilt remains the same as it goes around the sun. It's just that when it's over here, the tilt is going this way, away from the sun. But when it's over here, if my face is the sun, now it's the North Pole is tilting towards the sun and it's summer. Where if it's over on this side, you'll notice that the angle hasn't changed, but now we're away from, if my face is the sun, and the South Pole is towards us. So that's when we're getting into what all of these different things mean, is that how and where is the sun being most directly directed at the Earth. So there are some terms here: astronomy, axis, rotation, revolution, orbit. You should stop the notes right now and go answer those questions, and then come back and we'll keep going. So again, this is a quick review because we've talked about this a couple times, but I just want to make sure it's there. Earth's axis, that's that imaginary line that goes between the north and the southern poles. Earth always remains tilted based on that axis. So as the Earth rotates once on its axis, it completes one day as it rotates once around that imaginary line. So hemispheres, really talk quickly about this. We've got the northern hemisphere. Again, this is where we live. Here's that 23.5 degree, the Tropic of Cancer. So on the summer solstice, the sun will be directly overhead at the Tropic of Cancer. At the winter solstice in the northern hemisphere, the sun is directly overhead at the Tropic of Capricorn. That's the farthest 23.5 degrees south of the equator it goes. So the Earth is divided into two hemispheres, the northern and the southern. That imaginary line that divides the hemispheres is called the equator, and here is the equator labeled. So you'll see that a couple continents, South America and Africa, are actually bisected by the equator. You can literally be in one of those places and have a foot in each hemisphere, and that's kind of cool. We do have it if we go into Southeast Asia, into all these lovely little islands down here where we have a bisecting of the equator. So when you're really looking at this, remember the hemispheres. We live in the northern hemisphere. Australia, South Africa, most of South America is below the equator. It's south of the equator. So right now, as we're going into winter, they're just coming into summer, and vice versa when our seasons change. So let's review some of Earth's motions. And I'm doing this again and again because good teaching practices say that repetition helps put this in. And obviously this is going to be on the test, so make sure you're paying attention. The Earth spins on its axis and revolves around the sun. Earth spins counterclockwise when I'm looking for the northern hemisphere. What causes day and night, you say? It's that counterclockwise Earth spin around its axis as we face the sun and move away from the sun. Day and night is not because the sun is rising and setting. It's because the Earth is spinning on its axis. It's why the sun and stars appear to travel across the sky, and we're what's really moving. So if you could please now stop the notes again and go and watch this quick video. It's only 2 minutes long. I would appreciate that. When you're done, please come back to the notes. Welcome back. All right, Earth's tilt. We've said this a number of times. Do you think it's going to be a test question? Because I think it probably is, because I've said it again and again and again. Earth's axis is tilted at 23.5 degrees from the orbital plane of the sun. It's always here, whether it's here or this side, or if it was behind my head, it's always that 23.5 degree tilt. And that tilt is what causes the seasons. And if you look down at this picture, this again is just reinforcing, oops, didn't want to make that one larger. Huh, weird. It didn't really want to make me larger, but I don't know why that's doing it, but we're just going to run with it. So, oh, nope. We'll just go with it. If I'm looking here at the sun, and the sun's rays are hitting directly at the Earth, where it's straight on, you'll see that they're confined to a much smaller area than this angle of incidence. So if you look here, this angle of incidence shows you that that same amount of sunlight, if it was straight up here, we'd be getting it full on. But these light rays have to travel a much greater distance than they do where it's hitting directly. And that has to do with a lot more of what our temperature is like. So again, Earth's orbit, its revolution around the sun, happens every 365.25 days. That quarter day, remember, is why we have leap year, because as we turn into the sun, we're always a little bit off, and we're always just a little short. So we've got to make that one day up every 4 years. And there's actually more to it. There's stuff that happens on the century marks that are different if they end in anyway, it's a little more complicated to that. So there was some difference. It worked well in 2000, but it doesn't happen in some of the others. So you can look up leap year if you really want to find out what all it is. You just have to know that roughly every 4 years we have to add in a day. So again, Earth has seasons because it's the tilt of the axis as it moves around the sun. That Earth's tilted axis is that 23.5 degrees from vertical. We revolve around the sun, its axis tilts towards the sun. At the northern hemisphere, we're in summer. As the southern hemisphere's axis is tilted towards the sun, then it's winter in the northern hemisphere, but summer in the southern hemisphere. And if you happen to be here, okay, so let's take a look at this. Do you see here that the North Pole is in shadow and the South Pole is in sun? This would have to be our winter solstice. It is summer in the southern hemisphere, but it is winter in the northern hemisphere. As I rotate around in this counterclockwise motion, you're going to notice right here, look, the North and the South Pole are both in light. That has to be the equinox. We are coming out of winter, we're going towards spring. Equal day and equal night. As we go from spring, we enter counterclockwise to summer, and now you see the northern pole is tilted toward the sun, and the southern hemisphere is now in winter, but we're now in summer. This is going to be our longest day of the year. And as we come from summer, what we just experienced was the fall axis, and both, in this case, they're both in shadow because we're seeing the far side, the non-lit side, but then that also means both poles are being lit. You will see a picture like this on your test, which you're going to have to identify. If I tell you that this is the North Pole is in shadow, you're going to need to know that's our winter. If both poles are seeing the sun, that's an equinox. And if the South Pole is in shadow, but the North Pole is in sun, that's our longest day of the year in summer. So again, seasons. When sunlight strikes the northern hemisphere directly, the days are longer and hotter. It's our summer. Ironically, we have an elliptical orbit around the sun, and we are physically the closest to the sun during our winter. We are physically the farthest from the sun during our summer. It's that angle of 23.5 degrees that determines our longest, shortest days, which determines our temperature, not really our closeness to the sun. While sunlight is striking the northern hemisphere directly, it is striking the southern hemisphere at an angle, causing them to have shorter days and colder winters. So there, when we're in summer, southern hemisphere is in winter and vice versa. Again, this is just in here. If you want to go back and look at it, you're welcome to. Just a quick review. Latitude is that measurement of distance from the equator. It's expressed in degrees north and south. So the Tropic of Capricorn is 23.5 degrees south of the equator. The Tropic of Cancer is 23.5 degrees north of the equator. And solstices happen twice a year, once in our summer and once in our winter, and they are the longest and shortest days of the year. Equinoxes happen in the spring and fall, and they're the equal days and equal nights. This is actually a sunlight picture of an equinox. And this is where you'll see the sun is directly overhead at the equator. And you can see both poles are lit. If I look at the fall equinox, sun is directly over, okay, where's my picture? Here it is. So here's our solstices. This is the summer solstice, June 21st, in the northern hemisphere. You can see our North Pole way up here is in complete sunlight. The sun is directly overhead at that 23.5 degrees north, which is the Tropic of Cancer. And you'll notice down at the bottom during our summer solstice, Antarctica is in darkness. They're in their 6-month darkness period. The winter solstice, now the Arctic Circle, which by the way, there's no land underneath that, that's Arctic ice. That is in shadow for about roughly 6 months. And you're going to notice that the sun is directly overhead 23.5 degrees south, and that's the Tropic of Capricorn. And now Antarctica, the South Pole, is in its roughly 6 months of light time. So solstices are summers. Summer solstice is the longest day of the year. Winter solstice is the shortest day of the year. Equinoxes are equal day and equal night. Here is one more video that you should stop my notes and go and take a look at that. I'd appreciate it. And then come back. Welcome back. Okay, so if we're looking at this, this is a person, this is east and west, this is north and south. The sun's path at the winter solstice is much farther south than it is during equinox. Equal day, equal night. And during the summer solstice, it's much farther north. And you can see the difference. They show this. This is, you know what this is actually from? They do this to show people who get solar potential for their house, to show kind of why they need a kind of a southern facing to get a better track of the sun from sunset to, sunrise to sunset. So this is actually a picture designed to sell people something, but it's a really good representation. Okay, if my northern hemisphere is in shadow, you should be able to tell me right now what season we're having in the northern hemisphere when the North Pole's in shadow. What season is the southern hemisphere having when the South Pole is in light? Here are some more terms to go through, and here is a quick review of terms that you are welcome to go through. Astronomy is a study of the moon, stars, and objects in space, the Earth's revolution around the sun, and it rotates on its axis, affecting the night and day and seasons of the Earth. The Earth axis is an imaginary line through which the Earth that exits at the North and South Pole. Currently, the North Pole is pointed at Polaris, which is our North Star, but as we wobble, that will eventually be in about 14,000 years Vega, and then come back roughly 14,000 years later, and we're at Polaris again. So as the Earth rotates on its axis, the part facing the sun is in daytime, and when the Earth rotates away from the sun, it's our night. Why does the amount of daylight and change throughout the year? Well, it's that axis tilt of 23.5 degrees that causes the seasons. Seasons are caused by the tilt of the axis. And I think at this point, revolution and orbit, the Earth completes one revolution around the sun. It's called a year. The path that revolution occurs on is called the orbit. When you are done with these notes, make sure you have hit submit and that you've answered those questions. And as always, if you need help, ask me in person, jump on Zoom, whichever way it is that we're communicating. You can always email, but always ask for clarification if you need it. Have a great rest of your day.